In the vast silence of space, where time stretches and the stars seem frozen in eternity, one man-made object continues a mission that began before the internet, before smartphones, and before many of us were even born. Launched in 1977, NASA's Voyager 1 spacecraft now holds the title of the most distant human-made object from Earth, a lone traveler that has pierced the edge of the known and stepped into the eternal unknown. More than 45 years later, it's still sending data across billions of kilometers, from a place no spacecraft had ever dared to go, interstellar space. Imagine that. A machine built with technology older than cassette players, still whispering back to us from the farthest reaches of space. It's like a time capsule from a bygone era, one that not only continues to function far beyond its intended lifespan, but is also reshaping our understanding of the universe itself. What started as a 4-year mission has evolved into one of the most astonishing scientific journeys in human history. But the story of Voyager 1 and its twin, Voyager 2, is not just one of longevity. It's a tale of genius, timing, daring, and a bit of cosmic luck. In the late 1960s, a NASA engineer named Gary Flandreau at the Jet Propulsion Laboratory made a brilliant discovery using nothing more than a pencil and his knowledge of celestial mechanics. He realized that in the late 1970s, the 4 outer gas giants, Jupiter, Saturn, Uranus, and Neptune, would align in such a rare cosmic pattern that a spacecraft could use their gravitational pull like stepping stones, slingshotting from one to the next, dramatically reducing travel time. This perfect planetary alignment only happens once every 176 years. Faced with this once-in-a-lifetime opportunity, NASA didn't hesitate. In the summer of 1977, just 15 days apart, they launched 2 nearly identical spacecraft, Voyager 1 and Voyager 2. Their mission? To explore the outer planets and then, if successful, continue their journey toward the edge of the solar system and beyond. No one could have predicted that these machines, the size of a Volkswagen Beetle, would still be operating more than 4 decades later. During the early stages of their mission, the Voyager probes amazed scientists with close-up images of Jupiter's raging storms and Saturn's icy rings. They revealed Jupiter's moon Io erupting with active volcanoes and Saturn's moon Enceladus cloaked in glistening fields of ice. These moons weren't dead rocks. They were alive, dynamic, and full of geological surprises. The Voyagers forever changed how we perceive the outer solar system. Voyager 2 went on to achieve another historic milestone. It became the first, and still the only, spacecraft to visit Uranus in 1986 and Neptune in 1989. Its observations of Uranus's strange axial tilt and Neptune's deep blue storms unveiled worlds we had never imagined. Scientists were astonished. The data was like discovering the unknown pages of a cosmic book we had barely begun to read. But while these scientific firsts were making headlines, few knew the technological challenges that came with them. Each Voyager had just 69 kilobytes of memory, less than what your smartwatch uses to run a calculator. The computers on board weren't connected to anything. They had to make decisions on their own, relying on pre-coded instructions and limited artificial logic. Data collected by instruments had to be stored on tape recorders before being transmitted to Earth. And the radio transmitters? They used only 23 watts of power, barely more than a household light bulb. And yet, using massive 12-foot satellite dishes, these probes managed to beam messages across space, sending signals back to Earth that traveled at the speed of light. As they ventured farther, communication delays increased 4, even up to 18 hours just for a signal to arrive. Background noise from televisions, cell phones, and other devices made it increasingly difficult to catch their faint signals. But even in this sea of static, the Voyager probes spoke. And we listened. These spacecraft didn't just travel farther. They redefined how far we could imagine going. The Voyager mission pushed past Pluto, crossed the orbit of Neptune, and crept into the outskirts of the solar system. And then, something extraordinary happened. In 2012, after years of silent drifting through a near-empty expanse, Voyager 1 crossed a mysterious threshold known as the heliopause, the boundary where the sun's solar wind and magnetic field stopped dominating space, giving way to the influence of other stars. This was the moment Voyager 1 became the first human-made object to enter interstellar space. Scientists had expected a dramatic transition, An abrupt spike in cosmic radiation, a shift in magnetic fields, a noticeable change in space environment. Instead, the crossing was subtle, almost anticlimactic. There was no sharp change in magnetic direction, no sudden jolt of new forces. But one thing did stand out. The plasma density around the spacecraft increased, confirming it had left the protective bubble of our solar system. This baffled scientists. Why hadn't the magnetic field changed as expected? What was this quiet, mysterious space just beyond our sun's influence? The questions mounted, and Voyager provided the only clues. And so, the mission continued, funding extended, antennas tuned, and humanity's curiosity still burning. Meanwhile, Voyager 2, following a slightly different path, eventually joined its sibling in interstellar space in 2018. Together, the two spacecraft became humanity's silent ambassadors in the cosmic ocean, still transmitting their findings, still reaching farther than anything we have ever built. Beyond them lies the enigmatic Oort cloud, a theorized shell of icy comets and primordial debris left over from the formation of the solar system. It stretches halfway to the next star. Though it will take thousands of years to reach it, the Voyager probes are slowly drifting in that direction, silent witnesses to the Milky Way's hidden realms. And all of this, every photograph of Jupiter's moons, every radio wave from Neptune's edge, every bit of plasma data from interstellar space, was made possible by a spacecraft launched before digital cameras, before cell phones, before personal computers became common. In a world now powered by artificial intelligence and 5G, these twin relics from the analog age are still the farthest functioning machines ever created. They carry with them a golden record, literally. Affixed to each Voyager is a gold-plated disc encoded with sounds and images of Earth. Greetings in 55 languages, the cry of a baby, the hum of insects, the notes of Bach and Chuck Berry. It's our cosmic greeting card, our hopeful message to anyone, anything, that might someday find them. The Voyager mission isn't just about science. It's about hope, perseverance, and the power of human ingenuity. It's proof that even the smallest signal from the coldest, most distant place in the universe can remind us of who we are and how far we're willing to go to understand where we came from. So as these two tiny explorers drift farther into the dark, remember this: they are not just spacecraft. They are storytellers. And their story is our story. A tale of exploration, of courage, of wonder. If you've enjoyed this journey through time, stars, and science, don't forget to like, comment, and subscribe. The universe still has secrets to tell, and Voyager is still listening.